Hello everybody, I'm presenting the work Sintering and characterization of nickel iron antimonium and nickel magnesium antimonium alloys produced by powder metallurgy. This work is main objective is to evaluate the different phases that are involved during the sintering of such alloys. So in order to produce the powder, we weighed stoichiometric quantities of nickel iron antimonium and nickel magnesium antimonium, but then we mill it during 24 hours in dry conditions, and then the resulting powder were uniaxially compacted at 500 MPa. We produced two different kinds of samples of diameter of 8 mm diameter by compaction and 1 mm height by X-ray diffraction test and 6 mm height by dilatometer test. In both experiments, we are following the changes that are correlated in the results that I'm showing to you. We are looking that both kind of powder were obtaining irregular particles, that it's normal for this kind of processing test, and the size of particles were lower than 20 microns. After that, we are using dilatometry to following the change in the whole compact, and X-ray diffraction to following the change in the crystallographic phases in both alloys. Starting powders shows difference. When we are using nickel iron antimonium, we obtain the Heusler alloys after the milling process. Instead, when we are using nickel magnesium antimonium alloy, we reach a martensite phase that after the milling process. During the heating to reach at the sintering temperature that was 1100 degrees, we are notice that different changes are occurring in the crystallographic phases. We notice that the Heusler alloy, the Heusler phase, it's decomposed in different intermetallic compounds that it's not at this moment identified. After that, around 1000 Kelvin, we notice that the ordering of the Heusler alloys is obtained. This is confirmed by the different peaks observed in the deformation rate during sintering. We can notice that these peaks correspond with this formation of the intermetallic compounds. So we notice that this process is to order the final phase recorded, that is the Heusler alloy, and we notice also that these have an effect on the densification of the sample. So for the nickel iron antimonium, we obtain a less axial deformation, which is accompanied with a lower densification. The microstructure after sintering shows a larger lamellae that are composed mainly by nickel iron and nickel magnesium phases. These show also a residual porosity that is normally found between the particles. So we obtain at the end in both alloys the Heusler alloys that have the chain memory properties. So this process is promising to obtain this kind of alloys. As a conclusion, we can make that the difference between using magnesium or iron depends on the densification process and on the ordering of the Heusler phase alloy. So additional analysis is carried out to determine the shape memory properties. Thank you very much, and if you have questions,